There is a test on Thursday. What is today?
Tuesday.
Today is Tuesday. Today is Tuesday, so the test is not that far away. And yet I still have people who haven't finished the test from last week, so my goodness. There's good news and bad news about the test on Thursday. The good news is it's only 10 questions long. But that's also the bad news, because sometimes the shorter the test, the worse it goes. Now the reason it's so short is because how long it takes to graph, because you have to figure out the degree, the leading coefficient, the zeros, and graph it. So there's only 4 of those. So half the test is graphing. So half your grade will be from the graphing part, and I feel pretty confident that you can handle that. It's like 10, 11, and 12 that we did on our workshop yesterday. I feel pretty confident that you can handle that. That's what we've been talking about. That's what we talked about last Wednesday, Thursday, and Friday. We discussed it in our workshop yesterday. You already had to do like a maze on it. The one thing I'm missing for most people, though, is the page 12 in your notes. So have I seen that? You want to make sure I've seen that by the end of the period today. I'm typing in the zeros for those that I have not. Okay, yesterday we started solving equations, which is really just us practicing factoring. So the other half of the test is factoring, and sadly a lot of it's going to involve complex numbers, so we're going to have to go back to our packet today. But let's go ahead and do the easy factoring ones before we go to complicated factoring. I need help with workshop problem number 1. I need 2 things that multiply to negative 32 and add to negative 4. 8 and what? 8 and 4 sounds perfect to me, and your group can have a point. So m minus 8, m plus 4, negative 8 plus 4 is blurry. Negative 8 plus 4 is negative 4. Negative 8 times 4 is negative 32. So that's perfect. Good job. If we wanted to keep going, it didn't say we had to, but if we wanted to keep going and this equation was set equal to 0, where would our zeros occur? And his group gets another point. Okay, so let's move on to number 2. It's another easy factor. I need 2 things that multiply to negative 66 and add to negative 5.
Z minus 11 and z plus 6.
Z minus 11, z plus 6 are true. Negative 11 plus 6 is negative 5. Negative 11 times 6 is negative 66. Our true is correct. You can have the point.
Well, you said it.
You said part of it. You said part of it. You did not say the whole thing. If you want to lose a point, it keeps asking me. What are my zeros and you can keep it? Okay. Yes, okay. Negative 6 to 11. Perfect. Okay, let's go to number 3. I need 2 things that add to 13 and multiply to 40. This one's easy. Yes, dear, and you get your point. 8 and 5. 8 plus 5 is 13. 8 times 5 is 40. If we set this equation equal to 0, where are my zeros? And your group gets another point. 4 is the one we need to pay attention to today. It is the one most like our notes for the day.
Well, I just need y's.
Factor out a negative y.
Yes, so Seth pointed out why there's so many y's, but Arturo is telling me what to do with that. So let's pull out that negative y, and we're left with y squared plus 5y minus 6. Plus 6. Thank you, Arturo, and you can have a point for correcting me. So I've got this negative y. I need 2 things that add to 5, multiply to 6. Yes. And your group can have another point. 3 and 2. Okay, if I were to go back and set all this equal to 0 and ask you where my zeros are, do not break my heart. Tell me the right spots. Okay. She listed all 3. We'll give it to 3. I appreciate you, Mackenzie, though, for starting off with the 0, because Lord knows that's the one people are going to mess up on. I'm confident that Ontarius will get the negative 3, negative 2, but the negative y, and knowing that one's a 0, that's where most people go wrong. Are there any questions about the math workshop? Okay, so again, test Thursday, 10 questions. 4 of those 10 are graphing, but it's going to be worth half the points, at least half the points. I'm probably going to get worth most of the points. To me, the graphing part is the super important part. What we're doing today and tomorrow and what we did yesterday is important, but not as important as graphing. Okay, so get out your new notes. We were on the front page yesterday. We only did 4 problems. We only did 4 problems, and then we ran out of time. However, we went ahead and circled 5, 8, and 11. Why did we circle 5, 8, and 11?
Because they were going to be the hardest ones out of this grade.
They're not the hardest, but why did we circle them? They weren't set equal to 0, and Mackenzie gets the point. They were not. Okay, so we're starting off with number 5 and 6 today. We're actually going to handle 6 first. Why do you think I would say let's handle number 6 first? Well, but I already rearranged number 5, and now it's equal to 0. So why would I skip 5 and go straight to 6?
Because it has a 1 in front.
Because of the 1 in front, you can have a point. That leading coefficient of a 1 is why I'm picking it. It's going to be a little easier than that leading coefficient of an 8. But regardless, we're supposed to recognize it. Why are we supposed to recognize that 64? Why are we supposed to recognize that 64? Valeria, I'm dying. Let me turn it off. Thank you. It is a perfect cube. What cube is it? It is. And your group gets another point, and you're running away with the points today. 4 cubed equals 0. Great, Miss Compton. 4 cubed equals 64. Lord Jesus. Okay, so I'm looking at the sum of cubes. We're supposed to remember a certain acronym. What acronym is it? I heard you say it. Just be a little braver. It is SOAP. Kenzie, you said it first. You just weren't very brave with it. You can have the point. The S was for same. The O was for opposite. And then always positive. So since my sign is a plus, same would be a plus. Opposite would be a minus, always positive. Now you and I just have to figure out what goes in the blanks. We know that x to the third is x to the third. We know that 4 to the third is 64. So our hints are that it's an x and a 4 are what we're dealing with. We just have to figure out who to plug in where. And we've gone over this quite a few times, so if you don't remember, it makes me sad. Especially makes your grade sad, because there are 2 difference or sum of cube problems on the next test. There are 2 of them. You're supposed to know it. Does someone know it, or do I get to fill it in? I'm glad you know it, Miss Pfister. You and I will rock it out on the test. There is one on the test, the leading coefficient of a 1, so there is one like this. Sadly, the other one on the test is like number 5, the leading coefficient of a different cube. Someone be brave and not hurt my feelings. What goes in this first blank? Okay, we don't have all day, so I guess I'm going to not hurt my own feelings. X, 4. X squared, 4 squared, 16. X times 4 is 4x. This is not our first A to Z difference or sum of cubes. That makes me really sad that you haven't been paying attention, because we've done at least 3 different math workshops on that. So it's like the exponent thing all over again. It's supposed to be easy, and you're about to blow it. We realized it was x and 4. X squared, 4 squared, 16. X times 4 goes in the middle. Okay, sadly, people, that was the easy one of the day, because number 5 is harder because of that 8 in front. Now, it's still the sum or difference of cubes, because 8 is a perfect cube. What to the third is 8? Okay, so you're telling me 2 to the third is 8. X to the third is x to the third. So really, I'm thinking about 2x. Now tell me what cubed is 27. Yeah. So if I'm filling this in, I'm still using SOAP. Same sign, well, I have a minus this time. Opposite sign, so a plus. Always positive. I gotta fill in the gaps, but it's really not that deep. It's going to be 2x minus 3. I'm still going to do 3 squared on the end. 3 squared is 9, I'm still going to do 2x times 3 in the middle and get 6x. And then back here, I'm going to do 2x squared. So yeah, I'm still going to have the x squared part, but I also need 2 squared. What's 2 squared? 4. So it's still the same exact process. It's still here, square the guy, multiply the 2 together in the middle. It's the same exact steps. Just for kicks and giggles, we will do one more like that, and then we will talk about the answers, because sadly you and I, while we're doing a great job factoring, we've yet to actually reach answers on 5 or 6, so until we reach answers, we're really not done. Okay, so we did 5, 6, and we're going to do an extra one. I think we'll do, well, there's, oh, the whole back's about to be assigned, so no. Miss Brister's so nice. Miss Brister is so nice. I already did 3, I already did 4. 243.7. Ooh, I made a hard one. I don't want to do that. That's too hard. It's Tuesday. I still do an 8. Woo! 8x to the third minus 125. So what cubed is going to get me 8x cubed?
2x.
And what cubed is going to get me 125? Yes. So one of you be brave and get this right. For the soap, same sign, opposite sign, always positive. There are your signs. I just need someone to fill in the other things. Yes, 2x minus 5. What goes on the very? Yes, that one's going to be a 25. What goes here? In the middle is the 10x, because 5 times 2x is 10x. And what goes in the front, Kelsey? Yes. It's seriously, plug in those 2 guys for the front 2 slots. Square in, put them here. Square in, put them here. Multiply together, put them there. It's not that deep, but sadly this is like our 5th or 6th day to see this concept, and I've only got 3 people who feel confident with it. So, oh goodness, I'm telling you there are 2. You need to become more happy with it. Now, Miss Brewster was trying to make your life easier and still all my fun in life. So today I'm going over how to do it. Can you believe tomorrow you have to practice it? If you look on the next page of your notes, on the back of this, there are a ton of problems. There are 18 of them. Can you tell me how many of those problems are difference of cubes? Difference or sum of cubes? Thank you, Kelsey. You can have a point. 1 through 6. So you have 6 of these. You're about to get to practice. I know. Now, sadly, you and I are not done with our 3, so we need to go back and finish them. And we're going to do the lazy man's way of finishing them. What was the deal yesterday? Why was it taking us so long to do 1 through 4? What was the deal with the answers yesterday? They were what, ma'am? We had some imaginary numbers going on, and she can have a point for that. Sadly, today, we've still got imaginary numbers going on. So let's go to number 5. If we still set this equal to 0, then we would set each part equal to 0. So we would say 2x minus 3 equals 0, and this long thing equals 0. So I end up getting x equals some number. What is the number? You get a point. And you can have your point. And then I'm supposed to factor 4x squared plus 6x plus 9. And I'll go ahead and save your brain some worries. That is not factorable. Now, we are being super nice. And I'm just going to say, this one is my real answer. This is a real number. And this will give me 2 imaginary numbers. Now, while I need you to acknowledge they're imaginary, does that affect our graph? We talked about that yesterday. Yes, because it's not actually going to do what? And that's 3, 6, and 4 that get a point. So my understanding, when I graph this function, this cubic function, I know it's a snake, but it's only actually going to cross the x-axis once at 3/2. Those other two spots actually aren't on the x-axis. You do not have to factor it, and I'm just being a smarty pants. I'm just curious who else in the room is a smarty pants with me. Literally, that's all I need from you. That's all we're going to do on sum and difference of cubes. But for the smarty pants in the room, if I just had to know what two imaginary numbers it was, like I just got to know. If I needed to know, what could I use since I can't factor to figure out those exact two imaginary numbers? Going way back. With that equation, it's not factorable. We had other methods. What was another method you could use if something's not factorable to figure out the two solutions? We did not. You can't guess no imaginaries. We're not that good. There was, once I say the F word, you're going to know. There was a formula for it. Which formula? No, there's not, especially when it's a 2. I feel like it kind of tells you which formula it's supposed to be. So don't tell me like that and doing this triangle. You want to save the name? Quadratic formula. We could use the quadratic formula. You memorize that negative b plus or minus square root. We could figure out the two answers if we needed to. Sadly, we don't have to, so let's move on. Number 6, let's go back to it. It has two, I'm literally just going to put imaginary numbers. I'm telling you on all the difference and sum of cube ones, the second part that we get, the second part of the SOAP, not the first little binomial, but the trinomial, it's always going to be imaginary numbers. So there are always two roots that we're not actually going to see on our graph. Do I need you to acknowledge they're imaginary? Yes. Would they actually show up on the graph? No. But we do have one real number root. And I need to know what that real number is on number 6. Every group can have a point. And I need to know the real number answer on this one. And it would be x equals what?
X equals -4. Oh, 5 over.
Kelsey, you had it out first. You can have your point.
No, it's confused.
I know, because I didn't point well. I know, Arturo. Okay, so again, tomorrow, Arturo's job is to practice this, and 1 through 6 on the back is his practice of this sum and difference of cubes. The sad news is it's due on Thursday, but the good news is I'm going to post the key to this back worksheet that I'm assigning to you tomorrow night. So Arturo should practice it and make sure he's not crazy, because he has a test on this regardless on Thursday, but he will have a key to make sure he is not completely crazy as of Wednesday night. Okay, are there any questions about the sum and difference of cubes? Literally 1 through 6 on the back are this. So if you wanted to make a note, 1 through 6 on the back are the cube ones. I feel like it's obvious, but you know, sometimes it's obvious in things in life, not so much. Okay, I am excited about 7 and 8 because we've actually done this twice in math workshops, and both times you followed me. I just have never seen you do it yourself. So that's going to be the interesting part. That's going to be the interesting part. I'm especially excited about number 8. Number 7, Okay, what am I supposed to do first on number 7? It's factoring, people. What are we supposed to do first on number 7?
Factor out x squared.
And Arturo gets a point. If we factor out an x squared, we're left with an x squared plus 10x plus 21, and that's equal to 0. So we've got the x squared. I now need to deal with this. What times what is 21 and adds 10?
7 and
And Hunter gets the point. 7 and 3. Okay, I need to know my zeros. What are my zeros? -7. -3. No, sir. -7 from this one. -3 from this one. And then 0. Okay. Good. Now, there's something, if I was graphing, I would want to write down right now. A point for that.
Wait, was it?
No.
Wait, was it?
No, because Kelsey does. No. I could write down the degree as 4, but I knew that to begin with. What's something unique about one of these zeros that I should probably make a note of?
0.
What about it? And
And
she said it. I'll give you your point, but I'm giving it today too. It's got a multiplicity of 2. And in English, what does that mean happens at that spot on the graph? Okay, 3 is another point. Okay, so number 8, you're thinking, oh yeah, I can totally do this. It's going to be just as awesome. So we add 18 to both sides, and we have x to the 4th plus 11x squared plus 18 equal to 0. And now there is no GCF. Oh, no. We can't just stop because we don't know our zeros. We've actually done one like this before. And what I do is I use substitution. I say everywhere I see an x squared, I'm going to put a y. So my problem becomes y squared plus 11y plus 18 equals 0. Now, why would I change it to that? Because I don't know how to factor that line, but I know how to factor this. It's an easy factor now. I need 2 things that multiply to 18 and add to 11. I can totally do that. Yes. So I got y plus 9, y plus 2. And again, 9 plus 2 is 11. 9 times 2 is 18. So suddenly life seems pretty good. Now, I couldn't handle that line. But since we substituted and now we're talking in terms I like, I'm good to go. There's just one little tiny problem. From here, Miss Brister wants to guess that the zeros are -9 and -2, and she would be incorrect. We've got to plug back in. We were given in terms of x, so we've got to go back to x's. So we said y was x squared, so let's make it an x squared again.
X squared plus 9 and x squared plus 2.
Exactly. So we change it to just y, so it's an easy factor. But we've got to remember to go back to x's, because the problem was in x's, and our answer needs to be in x's, so we've got to go back to x's. And so suddenly what Miss Brister was going to thought the answers of -9 and -2, she suddenly doesn't have such pretty answers. Okay, sad day. We're going to have to set each of these equal to 0. So x squared plus 9 equal to 0. And I have to do x squared plus 2 equal to 0. Why is that so sad already? Tell me about these answers that I'm going to end up getting. I've got negative right here, which means eventually, like Miss Brister said, they're going to be imaginary. Oh, Miss Brister's already covered that. Okay, so I've got x squared equals -9 and x squared equals -2. We get rid of the squared by taking the square root. So I've got x equals
3i.
woo,
No,
3.
the other one, the 3i.
Yes.
So x squared equals 9.
It's going to be plus or minus 3i, but perfect. And our churro's right, and the reason that one works out is because we would have said it was x equals square root plus or minus square root of 9i. But you and I know the square root of 9 is 3, so that's how our churro jumps straight here. He knows the square root of 9 is 3. However, while our churro is a genius, we don't know the square root of 2. It's some decimal, and I don't want decimals. So I literally just want plus or minus.
The square root of 2i.
That's exactly what I want, and you can have another point. All I want is to not see a negative under the radical. I don't care if he leaves his it as square root of 3, square root of 5. As long as it's not a perfect square, he can leave it square root of 27. I don't care. Now, if it's 27, I wish he would simplify, because mine have 3. But anyway, I digress. As long as he's not leaving a negative under the radical and he's remembering to use his eyes, I'm okay. Did we have any real solutions on this problem? No, they're all 4 imaginary. So does that mean our graph crosses the x-axis? No, so literally it's an x to the 4th, so, and it's a positive leading coefficient. So what letter should it look like? Oh my gosh, Hunter, if you say use for a 4th one, you're going to hurt my feelings. You want to say a W or an M. You want to say a W or an M, and Kelsey was right when she for a second guessed the W because of the positive leading coefficient. But everybody sounded a little sketch when they said it, so I'm going to keep all my points. Regardless, it's going to be a W, yes, but that W never crosses the x-axis. Now, did you have to know this little tidbit? No. But is that how it all ties together? Yes. Okay, so basically, anytime it's x to the 4th, it could end up being a pain in the rear. So be worried. If it's an x to the 4th one, you might need to substitute. So look on the next page, on the back, how many problems are x to the 4th ones? What numbers? Yes, ma'am, and you can have a point for that. 7 through 12. Sadly, on 7 through 12, you need to substitute. Every single one of them does not have a GCF. How sad. So if I was making notes to myself, I would say 7 through 12, cortex, because that's what the title of the 2 we just did is. But maybe you realize that because it was x to the 4th and you're a genius. I don't know. Okay, so far, sadly enough, on the test, there are 2 that are summary difference of squares. Summary difference of cubes, sorry. Summary difference of cubes. There are 2 like this. And then there are 2 like the grouping ones. Would we like for Ms. Compton to stop overwhelming us today and us just go practice and she talk about the grouping ones tomorrow? That's what I thought. That's what I was planning on doing. So you and I both know you could handle 1 through 12 right now, and we'll talk about 13 through 18 first thing tomorrow. But it's actually the easiest of them all because you like grouping already. Okay. Work on this. I swear to you.